So I thought I'd walk through these problems in the textbook, and I'll just do the odds. That way, if somebody wants to post the evens for points, they can. They'd be good posts to make. I'm going to ask you these kind of questions on the exam next week, so that's why it's important that you know how to do these. So uh, the other thing I'm going to ask you on the exams, and I'm not going to tell you that these are log graphs, just like I'm not going to tell you that there's exponential graphs. And what you've got to do is know that which is which. And the way I know that this is a log graph, besides them telling me, is I'm seeing a vertical asymptote here. I'm not seeing a horizontal asymptote. See, exponential graphs have horizontal asymptotes because they don't ever approach that line. So that's going to be y equals a b to the x plus some constant, some shift up and down. Okay, so a log graph is going to look like y equals some stretch factor log, and I just treat these as log base 10 of x minus some left-right shift uh, plus some up-down shift, right? And maybe there's a reflection inside. We'll have that's all the things. But this is what I start with. Okay, let me stop and clean this up a little bit. Okay, so I know typically that log graphs look like this. They have their y-intercept, they have the vertical asymptote. So this would be like some log, y equals log x, right? Got a vertical asymptote of 0 because they can't take the log of 0, and across the y-axis there. And then usually I can find some other lattice point, some point where it crosses the grid that's nice and neat. Math actually tells you in a couple of them. So let's erase this. So what I'm seeing here is this graph not only is it what doesn't look like it's reflected on the x-axis. It looks like, because normally these things head off this way, this is headed off this way. It has been shifted to the right. To me, it looks like the vertical asymptote's at 1. So I'm going to write y equals a times the log of negative x minus 1 plus some constant. Okay, so I don't know if there's an up-down shift. We're going to check it out and see. So one thing I do see, it has a y-intercept of 0, 0. So if I use the point 0, 0, y equals 0, a is the log of negative 0 minus 1 plus k. Well, negative negative 1 is 1. We know the log of 1 is 10 to what power equals 1. Well, that's 0. So what that does for me is that tells me that k, because a times 0 is 0 plus k, so there is no up-down shift. And I verified it that way. So now we've got to find another lattice point. Let me see if I can erase that k without messing everything up. Well, pretty darn close. So I need another lattice point. I don't know, that looks like a pretty good lattice point. So that point is negative 3, 2. So 2 equals a times the log of negative 3 minus 1. And there's no k, of course. So 2 equals a times the log of, well, doesn't that become 4? That becomes negative 4, and then negative negative is a positive. So a equals 2 over log 4. So I could stop right here and I could say, okay, here's the equation of the line, of the curve that gives me that graph. So y equals 2 over log 4 times the log of negative x. I almost said negative x. Just a minute here. X minus 1. So that's that equation, and that works. Now, it's possible if this is the multiple choice question. Whoops, what's happening here? If this were a multiple choice question, it might say something like this. It might give you 1 over log 2 times the log of negative x minus 1. And where'd the log 4 go? Where'd the 2 go? But so if we've got to remember some of those log properties, 4 is 2 squared. Because it's a logarithm, I can bring that 2 down in front, that exponent rule, and then I can cancel out that 2. And that's where they got 1 over log 2. The other thing that might happen is we could think about this as a change of base problem. I could multiply this through. I could say 1 times the log of negative x minus 1 over log 2. And so if you think about the change of base formula says log base A of B is the same as log of B over log of A. In that case, that's what I have here. So that would be, I could rewrite this as log of 2 times negative x. These are all correct answers for the same problem. Honestly, this first one is a great answer. If you can get there, I'll be happy. This is just the added on stuff. It's part of that manipulation that you need to have a pretty good handle on manipulation in Calc. Calc 2 in particular, but Calc 1 even. You want to be able to manipulate logs a little bit. Okay, so I don't think I need to say anything else about that one. Let's do another one. If you want, you can stop this video, try number 19 all by yourself, and let me get some of this cleaned up, and then I'll give you some things to look at, and then see if you can take it from there. Okay, so for the number 19, I see a vertical asymptote at -4. I don't think it's been reflected around the y-axis because it would be headed like this if it was a normal log function. So there's just an x reflection, a reflection on the x-axis. And that'll come out when we calculate a. So you don't need to write a as a negative or anything. You just start the same way and take it from there. If you want, you can stop this video and take it from here and then come back and see how I do it. Or if you're really lost and want me to walk you through it, you can just continue watching. So I see a vertical asymptote at -4. So log of x, or a times the log of x plus 4, because it's minus a minus, plus some constant. See if there's a vertical shift up and down. And then I see the and x-intercept is -3. So that's the point -3, 0. So 0 equals a times the log of -3 plus 4 plus k, and 0 equals a times the log of 1. And of course, we talked about it earlier a minute ago, log of 1 is 0, so k is equal to 0. There's no vertical shift up and down, which makes it a little easier. No, actually, it's not that much harder if there is. You just got to include it when you do your calculation for a and everything. So then we got to find another nice lattice point. Oh, I don't know. -1, -2 looks pretty good. In fact, that probably looks like the best one. -1, -2. So -2 equals a times the log of -1 plus 4. And of course, there's no k. So -3 equals a times the log of 3. -2 equals a times the log of 3. So a equals -2 over the log of 3, which we can leave written as y equals -2 over log of 3 times the log of negative x. Dean, what the heck are you doing? Negative x. As x plus 4, right? That vertical asymptote plus 4. Let's see what I did. Yeah, it's plus 4. So that's that equation. Of course, you could always do that same kind of trick as I did down here, right? Where you could write that as -2 times the log of 3 times x plus 4. But that's advanced. You don't have to take it that far. Great answer right there. Okay, I'll do a couple more. Let's look at 21. What are you seeing? If you want to stop and try this yourself and then come back, you certainly can. And of course, you've got all the answers worked out for these anyways out of the Lippmann website, or Rasmussen website there, that open pre-calc website. I see a vertical asymptote at -2. I don't see any kind of reflection. It's just shifted left or right. So I'm going to say y equals a times the log of x plus 2, because it's at -2, plus k. Now I'm going to find a lattice point. Oh, it looks like that x-intercept's nice. So is 0 equal to a times the log of -1 plus 2 plus k. Well, that's log of 1, that's 0, k 0, no vertical shift up and down. That's a nice lattice point. 2 equals a times the log of 3. You probably were saying, what the heck, Dan? rightly so, rightly so. Y is, see, I should have done this. 2, 3. I keep myself from making mistakes when I do those kind of things. A times the log of 2 plus 2 plus k, which is gone. So it doesn't that give me 3 over the log of 4 equals a. So um, I don't know that rewriting this as 2 log 2 gets us anywhere, so I'm not going to do that. So I would write 3 over the log of 4 times the log of x plus 2 equals y, or f of x. So that's that equation. Okay. And then, let's see, what else can I do here? See how this one, so this one has a vertical asymptote. I'm going to assume it's at 5, okay? Um, I also know that normally log graphs head off like this. So I see this has been reflected around the x-axis. It's also been reflected around the y-axis. So, or the vertical axis. So what I'm going to do is I'm going to start off saying, let's see, y equals a times the log of negative x minus 5. You could write plus 5 plus some number k. Chances are k is going to be 0, but we'll verify that. Then it goes through the point 4, 0. So 0 equals a times the log of negative 4 minus 5 plus k. Do you see how that's going to log of 1? Log of 1 is 0. K is 0. So then we'll pick another nice lattice point. Oh, the y-intercept looks pretty good. So 0, negative 2. So negative 2 equals a times the log of negative 0 minus 5. So negative 2 equals a times the log of positive 5. So a equals negative 2 over log 5, which means I can just write y equals negative 2 over log 5 times the log of negative x minus 5. And that will do it. I mean, again, I could put it as log base 5 and leave the negative 2 out in front. Okay, so hopefully that helps you do these. Maybe one last thing. How do I know, and people, I only say this because people have done this on the exam. Sometimes they think a log graph is that they treat it like it's a rational function. So how do I know? Let's see, let me make some here. Here's a rational function. What do you notice about the graph, the domain? Well, I see, yeah, there's those vertical asymptotes there. This is actually acting like 1 over x squared. This is acting like 1 over x. And we could take it from there. You know, you would need to know the y-intercept, and it doesn't look like there's any x-intercept, so that would be but there is it would have to be a bottom heavy function, and because there's the horizontal asymptote is y equals 0, so we'd have to do some work with that. But this is a rational function because it's besides the vertical asymptote. It's defined for most x, versus with a log graph. Let me come back and delete this. Come on, delete it, delete it, delete. With a log graph, it's only defined over part of the domain. See, it's like this one, right? It would be here. Let's try this. See, that kind of, it has a vertical asymptote, but it's not defined over here. There's not a piece that's on the other side of it. So that tells me it has a limited domain. There's a VA at x equals, I don't know, let's make a number up, 1. At x equals 1, and then the domain is only x has to be greater than 1. So that tells me that's a log graph. All right, hopefully that helps. I don't know if you're going to watch this video this long, but I hope this helps.